That's not what I said I was gonna do.
Hey, we don't have a test today.
And his staff.
Wait, I had the discussion. Oh, I had that yesterday. I'm a day behind. Is it like poetry? He kind of showed me what am I going there right now? And I'm like, hi, I'm not going to be here tomorrow. And I'm like, oh, but you're actually not of the whole
We got there and we heard it was on. We should got there, we sat down, we were working, like, I don't know.
wait, but I have B lunch, so maybe I can go to lunch.
The test today. I would definitely keep it when we finish. I think the whole class is not like 5 people finish. I just
Wait, so you do get to take it home?
No, you're like not supposed to, but for some reason.
Was it that old guy again?
The thing is, if you call us, we have him.
Yeah.
Friday.
She's back on Friday. Just give it to him tomorrow. Oh. She's coming back on Saturday.
Yeah, okay, so basically I'm going home, right, and then I have to, and she's questioning for me, and then she's like, oh, she's like, how do I have it home? And I was like, and so I made a quick excuse, and I still went home, and then she's like,
So you were like genuinely gonna skip without her?
yes, and then and I was like, why is this so hard to happen? I am so here.
We went to Applebee's. I had us cutting down my Julius.
Olivia.
Yeah.
I did cut down this like a tree, like a dead tree. I got this huge rash on my arm. It's like going down, but you can still see the spots. Like it was so bad.
So unfortunate. Mine, there were leaves all over.
There were leaves inside of my socks. There were leaves inside of my socks.
No, when I came into my house, I was like, where are these?
We were like in the brush, like
Abby.
chopping down. Like it was so sad.
Not here.
I'm like, I feel so dirty. I feel so dirty.
Okay, take a seat, girls.
Take your seat, girls.
Okay, guys.
You should call Lucia.
I'm trying to. Okay, so I think I'd mentioned this. So Unit 4 that we just finished up the test on last class. That was the last of our new big unit assessments this semester. So we still have the final exam, and we'll spend some time reviewing for the final exam. The final exam in fall is not exemptable, but we don't make you take one in spring unless Mr. Myrick insists, and then I'll have to do what he does. So the random things that we have to clean up the rest of the semester is we need a little bit of time to study for the semester exam review. We're going to take a little bit of time starting Unit 6. Unit 6 is is probably the hardest unit of the entire year, but we won't have time to do all of Unit 6 until we return in January. Girls, please. We won't have time to test that until we come back, but by doing a couple of the easier units in December, that makes less to worry about in January, so I think in the long run that's better for you. So we've got that, and we've got a couple of random skills that we had just skipped initially. So there's one thing called L'Hopital's rule, which is great for doing limit questions, but I didn't show you that when we did the limits unit because you have to know how to do derivatives. So that's something we will do probably on Friday. We also need to talk about tangent line approximations. So we have talked about writing tangent lines. We have not used them to approximate values yet though. or very, 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 very little that we've done of that. And then finally, something called mean value theorem. So that's what we're about to look at today. And truthfully, mean value theorem really fits in the last unit, but I take it off of your last test because I feel like the last test has enough stuff. Critical numbers, increasing, decreasing, concavity, points of inflection, first derivative graphs, all of that kind of stuff. I feel like there's tons of information. So that's why I chose to take off the mean value theorem questions off of that test. But this is still a very important topic. This is one of the 3 big theorems in calculus. We did intermediate value theorem week 1, we did extreme value theorem in the last unit, and then mean value theorem. So you will have a 10 major point, this major points, not minor points, quiz before Thanksgiving break, but it will just be this one topic. So 10 points, you know, it's not as much as a test, but the trade-off is it's just one topic, so I think that makes it easier. So let's talk about what mean value theorem says and how it works. And today and tomorrow will be the only 2 full class periods we spend on this. I will give you some more class time on it, but today and tomorrow is going to be the bulk of the time I give you on mean value theorem. Okay. So in mean value theorem, when they say mean, they don't mean the not nice mean. They mean the math mean, which is to say what?
Average.
Right. Most common type of average is a mean. So what mean value theorem says, and it sounds like a lot at first, but I think you'll see that this actually kind of makes sense, and you probably never thought about it before, but it is pretty intuitive. There's 2 conditions that have to happen. One is it has to be continuous from A to B, and you have to include the endpoints, and it has to be differentiable from A to B. It doesn't matter if it includes the endpoints. So on the bottom of this page, I'll give you an example of one that's not continuous and then one that's not differentiable to show you why mean value theorem messes up. But assuming that's true, your graph's not jumping around, there's no sharp turns. Mean value theorem says that there is an x value C, they like to call it C, between A and B, x value A, x value B, such that the instantaneous rate of change, the change at an instant, which we call derivative, is equal to the average rate of change, which is just really the slope formula. So 9 times out of 10 when you're doing mean value theorem questions, you're taking the derivative and setting it in equal to the average rate of change, which is the slope formula. So let's just actually practice one of those, and then we'll look at this visual over to the right and graph this so that you can see what I'm showing you that we're finding. Okay, so you do really need to think about, is this continuous? It's a polynomial, so yes. Is it differentiable? If you're not sure if it's differentiable just means you can take the derivative. So you need to be able to take the derivative from -2 to 2. If you are not sure if you can do that, just find the derivative. You're going to need it anyway. And then see if there's any x values that give you imaginary numbers or division by 0 between -2 and 2. Not in this case, so it's fine. So again, all mean value theorem says is that the instantaneous rate of change derivative has to equal the average rate of change at least once. So to do the slope formula, make sure you subtract the y values, divide by, subtract the x values, so it's rise over run. And really the 2 things that can make these questions easier or harder are tougher derivatives. This is an easier derivative. And then in the slope formula, the arithmetic, you need to be extra careful. So got -16 plus 12 minus 2 is -6. And 16 minus 12 minus 2 is 2. By the way, when you do the slope formula, I know it's been a few years since this has been a class focus for you, but you can do these in either order you want to. You just need to be consistent in the numerator and the denominator. So I did f of 2 minus f of negative 2, so my denominator needs to be 2 minus negative 2. You can swap these two around if you also swap those two around. Okay, so we get negative 8 over 4, which is negative 2. So instantaneous rate of change, derivative equals average rate of change, slope formula. Now, on the longer questions, they are going to ask you to find that value of c. So find the value that makes this true. So you also have to solve this equation at times. So subtract the 6 over, divide both sides by negative 8, and take the square root of both sides. And of course, I forgot what? Plus or minus, thank you. When you take the square root of both sides, don't forget plus or minus. Now, if one of these answers was 10, that means that 10 is a x value that would make the derivative equal to the slope. But we only checked that it's continuous and differentiable between these values. So we really only want the answers between these values. So positive square root of 4 over 3 is between those, and negative square root of 4 over 3 is between those. So both of those are guaranteed by the mean value theorem. Now, technically, you can't include the endpoint. So if one of these was 2 or negative 2, you wouldn't count that. You only count the values between those two. So here is what we just figured up. I'm going to graph this for us to see. But I do need you to tell me the function, please. Is it negative 2x cubed
Plus 6x.
plus 6x minus 2?
Yep.
Thank you. Okay, so here was the function that I just worked with, but we really only cared about the values from negative 2 to 2, so make this easier to see. I'm going to have it only show me from negative 2 to 2. So on the right side of our equation, we found the overall rate of change. It's technically the slope of the secant line. Sorry, one sec. Okay. So we found the slope of the secant line on the right side of that equation. And what did we say that was? Negative 2? No. Is that what it was equal to?
Yes.
The slope formula? Okay. So if we only think about the starting point and the ending point, this is the average rate of change, and that was the right side of our equation. What we did in our work is we found the derivative, and we figured out when the instantaneous rate of change is also negative 2. And we got the square root of 4/3, which is like 1 point something, 1.2, so about right here, and negative that, so about right here. So what you need to see is that this slope of negative 2, the average rate of change, had to occur at least once, but we actually found both times. When x is the square root of 4/3, these were equal, and when x was negative square root of 4/3, these are equal. We're finding out that those are the same. Okay, so same idea over here. This is just a different visual, and again, I really feel like if you understand this visual, then you understand what we are finding when we find this c value. So notice we've got a function from a to b that is continuous. There's no breaks in the graph, and it's differentiable. There's no sharp turns in the graph. This red is thinking about the point at A and the point at B, and just what is the average, so slope formula. This is average. But because this is continuous and differentiable, mean value theorem guarantees there has to be at least one x value that we often call c that has the same. This slope and this slope are the same. So when you find where that's equal to, you're figuring out when those are comparable or equivalent. Okay, so let's make up a couple of examples to try to help you remember the conditions here. So I am going to draw something that is not continuous, and I'm going to show you that mean value theorem does not make sense. So here's A to B. It's definitely not continuous from A to B. The average rate of change, I just made up something really easy. The average is 0. You start where you end. And is there ever a time between A and B where the instantaneous rate of change is 0? Is there any tangent lines where the slope would be 0? Now, you've got some positives, you've got some negatives, but there's never going to be 0. So, mean value theorem's not holding up here because I drew an example of something not continuous. If your graph's skipping around, we can't predict nearly as much stuff. Most of calculus falls apart if you're not talking about continuous functions. Okay, differentiable, I can do basically the same thing, but this time to make it be, I'm going to make it continuous but not differentiable. So visually, remember the way that something cannot take the derivative is at a cusp, a sharp point. Your slope, your instantaneous slope can't go from positive something to negative something in an instant. It has to be gradual, like slope, little different, a little different, a little different, etc. Okay, so again, I am going to just kind of make up one where the average is pretty easy to see that it is 0. The rise over the run from the start to the end is 0. But there's no other instant, there's no instantaneous rate of change that's also 0. These guys are all positive, these guys are all negative, and the slope here is not 0. The slope here is undefined. At a cusp, there is no slope. It's not the positive before, it's not the negative after, it's the, at that instant, it's switching. So, nothing special about these two examples, but I'm just trying to show you that the average doesn't have to equal the instantaneous and if it's not continuous or if it was not differentiable. Okay, I've got 2 more examples I want to talk to you, to give you, and then I've got one past AP question at the bottom that I want you to try and see if you can figure out from what we've talked about. Okay, my next 2 examples are actually something called Rolle's theorem, and I don't take off the name Rolle's theorem on here because some of you plan on doing math competitions and stuff, and it's good for you to have heard this. But Rolle's theorem is just a very specific case of the mean value theorem. So if you know how to do mean value theorem, you automatically know how to do Rolle's theorem. Rolle's theorem is just the instance where the average rate of change is 0. Again, your AP exam will not say anything about Rolle's theorem. You don't have to know it. I wouldn't put it on your test. But it doesn't hurt for you to hear, and it gives us a couple more practice questions. Okay, so question 3. Find all numbers C guaranteed by mean value theorem or Rolle's theorem, whatever, for this function from 0 to 4. So Rolle's theorem is mean value theorem, so it has the same conditions. This needs to be continuous from 0 to 4, including the endpoints. A polynomial is always continuous. Notice we don't get any imaginary numbers from 0 to 4, and we don't get any division by 0 from 0 to 4. And then differentiable means you should be able to plug in any number bigger than 0 and less than 4 and it not give you undefined in the derivative. Now, if you don't know if that's the case, that's okay, because you're going to find the derivative anyway. So find the derivative, see that it's 2x minus 4. You can plug in numbers between 0 and 4 into 2x minus 4. You're not going to get undefined. So the conditions are being met, And so now we can say the instantaneous rate of change, 2x minus 4, has to equal the average rate of change. And how do we get average rate of change? The slope formula. So plug in 4, 16 minus 16 plus 1, minus plug in 0, you get 1, 4, I don't know, you get 0 over 4, which is 0. Again, if the average rate of change is 0, that's the only thing that makes the special case of Rolle's theorem. So this happens at x equals 2. X equals 2 is between 0 and 4. Again, if 0 came up or 4 came up, you wouldn't keep those, but you'd keep the ones between them. At x equals 2, the slope of this line is the same as the slope of this line from 0 to 4. So again, I think the picture is just too important. So I'm going to graph it. Is that +1 or -1?
+1.
+1. Thank you. Okay. So here's the function we just worked with. They told us to only bother with 0 to 4. Okay, and then if you think about the rate of change from the start to the end, this represents the average. And what did we get for the average rate of change? 0. And then we tried to figure out when the function also has a slope of 0. So that looks to be about right here. And that looks to be at x equals, what's that? 2. That's what we just did algebraically. X equals 2 is when the instantaneous rate of change equals the average rate of change. Okay, so one more time. All right, is this function continuous from 0 to 2? And how do you know?
It is because it's a polynomial.
All right, polynomials are always continuous. Perfect. Is it differentiable from the open interval 0 to 2? Well, if you're not sure, take the derivative first. And then think about, is there any time that gives me division by 0? Is there any number that would give me the square root of a negative number? Things that wouldn't show up on a graph. And I don't have that problem, so conditions are met. So figure out when the instantaneous rate of change equals the average rate of change, slope. So the ending y value would be five. The starting y value is 5, and you're traveling a distance of 2, but that ends up being 0. Again, technically that's what makes this Rolle's theorem, because this came out to be 0. Again, don't worry about the name Rolle's theorem. This is just a specific case of mean value theorem. And then for us to figure out when this happens, we have to solve this equation. So sometimes that's just adding and subtracting to both sides. Sometimes it's square rooting both sides. If it's a quadratic, it's probably going to be factoring both sides. I'm glad that you guys don't do the, one of my classes was saying that they don't know how to guess and check, and I was just still struggling with that. Oh, was that y'all?
That was our class.
Okay.
That's it, actually. That's tough.
Oh, I can't believe that class.
Yeah, I can't believe one of your classes didn't know how to guess and check. That's really embarrassing for me.
It is embarrassing. It's going to be even more embarrassing if I don't figure this one out.
Maybe you don't know how to guess and check or something.
I probably don't.
Well, then maybe you
That's
should
not-
clown your other class for,
I can do A times C also.
Look, you did it wrong.
I did do it wrong. I have a backup plan though.
What is this?
Yeah, wait, what's that?
A times C over 6, B over -6.
I'm not teaching you factoring. That ain't happening. This has to factor, right? Because I factored it first period this morning.
Multiplies to 6 and adds to -6, there's nothing.
Yeah.
Okay. Okay, I guess I told them wrong, but they didn't say anything, so that's their problem. Okay,
So maybe it's embarrassing for them.
then am I stuck? Is factoring the only way to solve a quadratic? Okay, I'm gonna do this as slow as possible, and I want to know why y'all are so whiny. A, B, C. Opposite of B, plus or minus, square root, B squared minus 4AC over 2A. 6 plus or minus the square root of 12, which is 2 square root of 3. Or divide everything by 2. Is it really that bad?
Yeah. I just hate the freaking song.
But actually, one of these probably wouldn't work because, again, they'd have to be the values between 0 and 2. So 3 plus the square root of 3 over 3 is about 1.5, so that's fine. And minus is 0.4, so that's fine too. But that's worst case. Quadratic formula is worst case. Okay, so I want to do two things before we look at the circuit, and one of them is I want you to try this multiple choice question. Just give it your best shot. This is a real AP question. If I've never told you before, students who take Cal BC, 60% of their AP exam will be the exact same as your AP exam. So even though this was on a BC exam, this is really an AB topic. So you don't have to think that you can't do it because of that. So read the question and then see which one of those answer choices you think is most appropriate. It changes every year.
But like generally.
I don't know, 55 would probably be pretty safe. No, because the BC exam gives 2 scores. It scores all the AB stuff, and then it scores all the BC stuff. So if you aced all the AB stuff, you would get AB credit, but you wouldn't get BC credit because you'd be missing on the BC stuff. Also, I'll give you a hint, the 4 wrong answers are all wrong for the same reason.
Well, then it's probably just.
The answer should be pretty obvious. Does one of these not stick out a little bit more?
The last one.
Okay. There is a C between 0 and 4 such that the instantaneous rate of change is 0. Why are they saying 0? I hear too many responses from my brain to pick up. Why is the average rate of change 0? Right, so it doesn't go up at all.
No, it's not that one. Oh, that's tough. Maybe I should have drawn it.
Okay. This is the one that's correct. They're basically saying they're basically stating mean value theorem. Why, girls, back on the board, please. I'm gonna have to separate y'all if you can't stop when you need to. Why was mean value theorem okay in this question? You can't just use mean value theorem whenever you want to.
continuous and differentiable.
Right. Because they said that, that's why mean value theorem was free game. Okay, why does A not work? The minimum value between 0 and 4 is 2. I look at all these y values, the minimum is 2. So why can that not be correct? Y'all think 2 is the minimum value? It could be. Where could it be smaller than that, though? This is just a table. I know the value at 0, 1, 2, 3, and 4. But what about everything between 0 and 1? Everything between 1 and 2? This might, at x equals 0.5, y might be negative 10. It might be smaller. You don't know what's going on between these. You only have 5 snapshots of what's going on. You can't assume the biggest value is one of these 5. You can't assume, or the smallest. You can't assume the biggest value is one of those 5 because anything could be happening between these points. I know it exists between these points. They tell me it's continuous. They just don't tell me what those values are. Okay, this is saying y is always positive. These values always look positive, but again, you still don't know what's going on between these values. So that's not guaranteed to be true. And then this one's not even close to being true. What is this one saying? The what is negative?
Slope.
Exactly, the slope is negative. And you can see right here, it's going up. From 0, 1, 2 is going up from 2 to 3 to 4. So the slope's not negative there, so it's certainly not, oh, well, they said from 2 to 4, my bad. From 2 to 4, I guess the slope is going down. But again, you don't know what's happening between 2 and 3, and you don't know what's happening between 3 and 4. You can't assume that that is like just connecting the dots and it's a straight path between those. These are all assuming, any one of these, you're assuming that you know what's going on between those points. This one's mean value theorem. You know it's true because it's continuous and differentiable, and this is what mean value theorem says. There has to be an x value c somewhere between 0 and 4 such that the instantaneous rate of change derivative equals the average rate of change, which happened to be 0 because you started and ended at 2, but it could be anything. Okay, before we slide over and talk about the circuit and try to knock out a couple of questions, because again, we have tomorrow as well, I wanted to sidebar for a second, and I have a puzzle for you guys today over on the TV screen. And I would like you to try it and see what your gut reaction is. Again, I'm old, so I can't read it over there. What's the speed limit? 30? 35. Okay, so.
Look, they're so happy. They're driving shoes.
Okay, there's my 2 police officers. The first police officer records you going how fast?
35.
35 miles per hour. Okay, you drive 1.2 miles or something. And then you reach this guy and he clocks you going how fast?
30.
30 miles per hour. Okay, so the first cop sees you do 35 miles per hour, the second cop sees you do 30 miles per hour. They pull you over and you go fight this ticket in court. what's gonna happen? Do they have enough proof that you broke the speed limit? Why do they have enough proof?
Because he went, 1.2 miles in 1.5 minutes.
You went 1.2 miles in how long?
1.5 minutes.
Okay, so 1.2 mile, hold on, 1.2 miles in
1.5.
1.5 minutes? Okay, so these are in miles per hour. I want to think of this as miles per hour also. So let me change 60 minutes is the same as 1 hour. And 1.2 times 60 divided by 1.5 is 48 miles per hour. Okay, what did I just find? The average. I know how long it took. I know how long it took him to go that long, that far. So that's the average. So we know he broke the law, right? How can they prove that you did 48 miles per hour though? Your average equal to your instantaneous mean value theorem. The average has to be equal to the instantaneous at least once. You only have two options here. Either you go 48 miles per hour the entire time, right after they see you and right before they see you, which is way faster than the 35 miles per hour, or let's say this is 35. You can go less than 35, but if you go less than 35 sometimes, what also has to be true?
You have to go faster than the
Right, if your average is 35, if sometimes you're going slower than 35, sometimes you have to go be higher than 35. So your instantaneous has to equal your average at least once. They can prove in court that you had to go at least 48 miles per hour at least once. So yes, they can give you a ticket. Now, are they going to say mean value theorem and talk about calculus? Probably not, but I mean maybe. I don't know. But yes, that's pretty easy to prove.
Would they actually do that?
Sure.
Like sit there and time you.
Huh?
They like sit there and time you. Well,
Yeah.
Has that ever happened to you, Mr. Ryan?
That's not happening to me. I would not speak.
Personal anecdote. You would not speed, is that what you said?
Yeah.
You never reported.
What my point is that this concept of like if you average $100 a day at work, then you either make $100 every day, or some days you make more, some days you make less. But there's at least some days or some instances. If your average is $100 a day, there's instances where your pay is exactly $100 a day, even if it's just once. If it's higher half the time and lower half the time, it has to be. If it's continuous, there's got to be one time where they're the same. So, even though it seems like an abstract idea, it is very much in the real world. Okay, so I don't want you guys to have to do the entire circuit tomorrow, so I would like you to try, we've got 10 minutes here, so if you would just try to maybe do one or even two of these while you are here, and then if you would try to do one or two for homework between now and tomorrow, then that will help your understanding and help you not feel rushed in class tomorrow. So again, 9 out of 10 questions is going to be find the derivative, find the slope, using the slope formula, set them equal to each other and solve. Find the derivative, find the slope, set them equal and solve. Instantaneous rate of change, average rate of change, and then figure out where it happens. And again, this one topic is gonna be a 10-point quiz before Thanksgiving. So even though I'm only asking you to do 1 or 2 in class and 1 or 2 outside of class between now and tomorrow, you know, if you have time to work ahead on the circuit and do these things early so you have more study time, obviously that is gonna be better for you if you have time to do that. But
Oh. What do you? They're both weapons.
Also, I guess why this is fresh in my head, I honestly don't know if cops do that very often. I know that's very reasonable, but I can think of one situation where they probably do it all the time, and that would be truck drivers, because if a diesel truck is always going 10 miles an hour faster than they should, they're going to see that in their logs because they watch that stuff very closely. And they're going to know that they're not a safe driver, and that's going to be a problem. So.
Do you not like drive like 5 over the speed limit?
Huh?
Do you not like drive like 5 over the speed limit? I feel like that's pretty normal.
That's basically the speed limit.
That's the, I don't think I will get pulled over for
Yeah,
this.
exactly.
That's a risk, I mean.
Well, no, I know somebody who took it to court and that they were only going 5 over.
Depend on the judge, I guess, I don't know.
If everybody's.
You wanna have to go to court to fight it?
Yeah.
Or do you wanna show up 30 seconds later?
I want to get there 30 seconds earlier. My time is not equal.
Yeah, but it only takes one time of being pulled over, you lose all of that time you ever saved. And then what do you do when a deer runs out in front of your car and you have that much less time to react? Or the car in front of you slams on their brake and you have that much less time to react?
Well, see, that's true.
Not if you don't give it enough time. If you're going 50 miles an hour,
I don't start in the park.
if you're going 50 miles an hour, how much space do you need between you and the person in front of you?
Huh?
You're going 50 miles an hour, how much space do you need between you and the person?
It just depends on
No, it does not.
1.5 car length.
No.
Mine has like a thing that measures.
It's
the
one car length for every 10 miles per hour.
Really?
Yes.
That's crazy.
No. No, you didn't.
A full car length.
You said, well,
So
oh, I didn't hear
feel like,
her that.
But I feel like the time, well, I mean, I normally do. My thing
So 5
is
car
when people
lengths.
sneak into that car lane and cut.
I said 50.
Yeah.
That's what makes me mad. So I try to do like,
Yeah, people get
I
like
try to do
cutting
like
and
5/6
then,
of a car lane because I'm not about to get cut off every day. That
You know,
happens
if
to
you
me
hit
all
the person
time.
in front of you, it's your fault no matter what.
Yes, but also, you know, there's that scam that people will like back into you and
That-
then
I
like
have
make
seen
it.
that.
Have you seen that?
Yeah.
And then it's like your fault. That's like my biggest fear.
That's why you need a dash cam.
Dash cams are like, you have to like
I
have
have a
somewhere to
Chevy
put all the
Colorado.
footage. Like, I
No,
don't-
it like relays every
Are you
24
serious?
hours.
Well, my mom wouldn't give me one because she was like, no, I don't want to have to get stuff for, because I want to go save the footage.
That was actually, me and my wife decided to get each other dash cams because I got hit last year, I don't know, someone hit me behind
By
me.
a student?
No,
That'd
no,
be
no.
funny.
But, so we bought them for Christmas, that was what we were gonna get each other. And we literally did not buy them until like 2 weeks ago. They're sitting in our living room waiting to be installed.
I need a dash cam, but also like, I don't know. I just
We will certainly finish the circuit. We're probably all so tomorrow is Friday. will do a circuit on the local Charles School. The good news is it's going to take about 3 minutes to explain it, and the practice won't take as long. So I actually expect that very, very, very inclusive. I'm not expecting it to
No, it's all on the.
It'll all be on there. Actually, the L'Hopital is probably already on there. I mean, the class recording's not up obviously yet, but I'll be here tomorrow. No, I can't.
Wait, I can see his dress. Mr. Thompson, you drive a truck? No, you're allowed to. I just
Buy something, decide to different kids and trade it in 6 months or a year later. And so that truck, you just kind of trade it in, and the trading card, they don't offer you here. So he offered it to us for the same price the dealership was gonna give it. So it's such a good deal. I wasn't like really buy another car.
Yeah, $40. So yeah. And yeah, if you don't get it, do you have like a really nicely landscaped yard?
My dad used to.
Please help your mom. I would a big amount last year, and we went to see that.
No, it's never good.
I was like, it's not easy to do that after people like yearly after you
Alright, have a good day.
Oh, yeah. For what?
Thank you.